Have you ever wondered how computers understand what we want them to do? They don't speak English, French, or Mandarin. They have their own language, a language of instructions called programming languages. These languages are the bridge between human thought and digital action. Just like we use words to form sentences and tell stories, programmers use programming languages to write instructions that tell computers how to perform specific tasks. From the apps on our phones to the software that powers our cars, programming languages are the invisible force driving our technological world. Every time you open an app, send an email, or even just scroll through a web page, you're witnessing the power of programming languages in action. Understanding the basics of how these languages work can give you a whole new appreciation for the technology we often take for granted. In the early days of computing, programming was a very different beast. Imagine giant, room-sized machines and punch cards used to input instructions. Back then, languages like Fortran and COBOL were all the rage. Fortran, short for formula translation, was developed in the 1950s and quickly became a favorite among scientists and engineers. It was perfect for crunching numbers and performing complex calculations, laying the groundwork for everything from weather forecasting to rocket science. COBOL, on the other hand, stood for Common Business-Oriented Language. As its name suggests, COBOL was designed for the business world. It excelled at handling large volumes of data and automating business processes, making it a staple in industries like finance and government for decades. These early languages were groundbreaking for their time. They proved that computers could do much more than just calculate. They could process information, automate tasks, and even simulate real-world scenarios. As computers became smaller and more powerful, programming languages also evolved. The introduction of keyboards and monitors made programming more accessible and user-friendly. New languages like C emerged, offering programmers more flexibility and control over computer hardware. C was a powerful general-purpose language that became the foundation for operating systems, software applications, and even other programming languages. This period marked a shift from specialized languages tailored for specific tasks to more versatile languages that could be used for a wider range of applications. This era also saw the rise of structured programming, a way of writing code that made it easier to understand, debug, and maintain. The 1980s and 1990s witnessed the rise of object-oriented programming, OOP, and languages like C++ and Java that embraced this paradigm. OOP revolutionized software development by introducing the concept of objects that could contain both data and the procedures that operate on that data. This approach made it easier to build complex software applications by breaking them down into smaller, reusable modules. C++ became a popular choice for developing system software, game engines, and high-performance applications. Java, with its write once, run anywhere philosophy, gained traction for its platform independence. It allowed developers to create software that could run on different operating systems without modification, a significant advantage in the rapidly expanding world of personal computers and the early internet. This shift towards object-oriented programming and platform independence laid the foundation for the development of even more powerful and versatile languages in the years to come. Section 5, A Whole New World, the Internet changes everything. With the explosion of the Internet in the late 1990s and early 2000s, programming languages had to adapt to a whole new world. The demand for interactive web pages, dynamic content, and web applications led to the rise of languages like JavaScript and PHP. JavaScript quickly became the language of the web browser, enabling developers to create interactive and dynamic elements on websites. It brought web pages to life with animations, visual effects, and responsive user interfaces. PHP, on the other hand, emerged as a server-side scripting language, powering the behind-the-scenes logic of websites. From handling user logins and processing forms to interacting with databases, PHP became the backbone of countless websites and web applications. These languages were instrumental in shaping the Internet as we know it today, making it possible to move from static web pages to dynamic and engaging online experiences. Section 6, the big players today: Java, Python, JavaScript, and more. Fast forward to today, and the landscape of programming languages is more diverse than ever. Java, despite its age, remains a powerhouse in enterprise software development and Android app development. Its stability, scalability, and large community of developers keep it relevant and in high demand. Python, known for its readability and beginner-friendliness, has exploded in popularity in recent years. It's widely used in data science, machine learning, web development, and scientific computing. Its vast ecosystem of libraries and frameworks makes it a versatile tool for a wide range of applications. JavaScript, once relegated to web browsers, has also evolved into a versatile language used for both front-end and back-end development. Its frameworks like React, Angular, and Node.js have become ubiquitous in web development, allowing developers to create complex and dynamic web applications. These are just a few examples of the many popular programming languages used today. Each language has its strengths and weaknesses, and the best choice for a particular project depends on factors like the type of application, performance requirements, and developer preference. Section 7. The masterminds behind the code. Behind every successful programming language is a brilliant mind, or often a team of minds, who poured their creativity and ingenuity into its creation. These pioneers of programming didn't just invent languages, they shaped the way we think about and interact with computers. Grace Hopper, a computer science pioneer and United States Navy Rear Admiral, is credited with developing the first compiler for a computer programming language. Her work paved the way for the development of higher-level programming languages that were easier for humans to understand and use. Dennis Ritchie, a computer scientist at Bell Labs, developed the C programming language, which became one of the most influential languages of all time. Its impact can be seen in countless operating systems, software applications, and even other programming languages that were inspired by its design. James Gosling, a Canadian computer scientist, is known for creating the Java programming language. His vision of a platform-independent language that could run on any device helped shape the internet as we know it today, enabling the development of countless websites, web applications, and mobile apps. These are just a few examples of the brilliant minds who have shaped the world of programming. Their contributions have had a profound impact on technology and continue to inspire new generations of programmers today. Section 8. Learning to speak. The language of the future. Learning to code is no longer a niche skill reserved for computer science graduates. It's becoming an essential skill for anyone who wants to thrive in our increasingly digital world. Whether you're interested in building websites, developing apps, analyzing data, or automating tasks, learning to code can open up a world of possibilities. The good news is there are more resources available than ever before to help you get started, from online courses and coding boot camps to interactive tutorials and supportive online communities. There's a learning path for everyone, regardless of your age, background, or learning style. The key is to find a language that interests you and a learning method that fits your lifestyle. Don't be afraid to experiment with different languages and resources until you find the right fit. The most important thing is to start learning and to never stop exploring the ever-evolving world of programming. Learning to code is not just about acquiring a technical skill. It's about developing a new way of thinking, a way of breaking down problems and creating innovative solutions. It's about becoming a creator, an innovator, and a problem solver in a world increasingly driven by technology. Section 9. Programming, the language of progress. Programming languages are more than just tools for writing instructions for computers. They are the building blocks of our digital world, the invisible force behind the technologies we use every day. They are the language of innovation, enabling us to create new possibilities and solve complex problems in ways never before imagined. From the early days of punch cards and mainframes to the age of artificial intelligence and cloud computing, programming languages have played a pivotal role in shaping the world around us. As technology continues to advance at an unprecedented pace, one thing remains certain. Programming languages will continue to be at the forefront of innovation, driving progress and shaping the future. Understanding the basics of how these languages work and the history behind their development can give you a whole new appreciation for the technology we often take for granted. It can also empower you to become a creator, an innovator, and a problem solver in a world increasingly driven by technology. So, the next time you open an app, browse the internet, or interact with any form of technology, remember the invisible force of programming languages that makes it all possible. They are the language of progress, and the possibilities they unlock are limited only by our imagination.